is 8.1b. It has a very, very similar concept to 8.1a. So a few things to keep in mind is that your series will be centered at x equals 1, not x equals 0, so keep that in mind. So we're looking at that point there. And we pretty much need the zeros of this leading coefficient. And we need those zeros because we need to know where this function equals 0. Because when we divide through by this coefficient to all the other terms, obviously this term will be on the bottom, and the zeros of that function will cause division by 0, which everyone knows is a big no-no. You don't do that. Division by 0 is bad. So we're trying to avoid it, and that's why we're locating the singular points. So if you remember, your minimum radius of convergence will be the minimum distance from the nearest singular point. So that's a way to get a guaranteed radius of convergence for a power series that you don't necessarily know where it's going to be valid. So like on the last example, Dr. Noring gave you the zeros, which is super nice. And I went ahead and plotted those zeros on this graph paper type thing. Again, for anyone who's not familiar with the complex plane, your x-axis is your real numbers, while your y-axis is the complex. So we have our real numbers, -4, 2, and 3 happening over here, and then we have the real portion of these complex conjugates here plotted. So we have our +1, and then our -1i, and then our +1i, which created these two little points right there. So hopefully that makes sense. So now we're just going to plot the distance from each of these points. So if we're starting at 1, I, positive I, so the distance from x equals 1 and then x equals 1, I is just going to be 1, yes? And similarly, we can say the same thing about -1 to 1. The only difference is 1. One little point up in the y direction. So we have 1, -I, distance is also 1. Okay, so let's move on to x equals 2, well, I guess 0.2, 0. So if our origin is at 1 here, how far is our x equals 2? Will just be another 1. So 1s are really ruling the board right now. So moving to our next point with the 3, 0. So our 3, 0 will give us something other than 1, hopefully. Well, actually, it will. So what is the difference between 3 and 1? Give you a distance of 2 here. Okay, and then lastly, we have our -4, 0. And then the distance between the -4 and then your origin at x equals 1. So 1, 2, 3, 4, 5. We get 5. So we have a lot of numbers going on here, but remember that your minimum radius of convergence is going to be the shortest distance to the nearest singular point. So in this case, we have 3 points hovering around this radius that would cause problems. So that's why we can say that our minimum guaranteed radius of convergence for this power series solution is 1. And hopefully that was helpful. Let me know if you have any questions whatsoever, and I'll do my best to answer them.